Hello, thanks for joining us for our presentation on NASA's Rock On 2026.
I'm Travis Smith. I'm an undergraduate student of engineering at DMACC.
I'm Kaylee Qualls. I'm also an undergraduate student of engineering at DMACC.
And our team was also represented at Rock On by Professor Shree Banjara, Professor of Physics and Math at
We'd like to go through an overview of why we came and what we did while we were here, and the results of our work, and what we learned throughout this experience.
So to answer the question of why, we wanted to learn some new skills through hands-on work, find fellowship with like-minded people, be inspired towards future creativity, and honestly, rockets are cool.
To start out the first day, we built a little circuit board that just blinked some lights so that we could get some practice soldering components and reading circuit diagrams.
I've never successfully soldered before, and by the end of the first day, I was able to make perfect solder connections, which built up a lot of confidence that we were going to be able to do this. It was a lot simpler than
Uh,
I imagined it to be.
I'd done some soldering before, but it was great to get a little bit of practice before we started working on the hardware that was actually going to go into space.
So after we built that first bit of practice, on the second day, we moved on to building the Geiger counter from scratch. So by the end of day two, we actually had a working sensor that we could actually test, and it actually clicks just like you would expect a real Geiger counter to. You won't see that, or you won't hear that necessarily on this video, but there's actually an LED, and every one of those LED light ups is it detecting a neutron.
They gave us a little piece of Fiesta ware with some radium pigment in the paint, or no, uranium pigment in the paint to test the Geiger counter. And then after we had the Geiger counter working, we started integrating everything within Arduino. We had several other sensors, and we also had to stake all the wires and connections, just hold them down with hot glue so that they didn't come apart during launch.
If you ever go to this, you don't have to be a programmer to um, work through this. They actually guide you step by step through the Arduino programming and explain what's kind of happening with it. Um, Arduino programming is really very simple, and the way they explain it makes it very easy to understand. It was actually a lot of fun to put it all together. In addition to the Geiger counter, we also had an accelerometer, pressure sensor, humidity sensor, magnetometer, and gyroscope. And we actually took a picture of the completed project and labeled everything for people to see.
Along the way, we were testing everything to make sure it worked. They had these great checklists for us to just make sure, step by step and make sure everything was working. And they also had volunteers helping out who would double check our stuff just to make sure everything would work when it actually got up into space.
Speaking of volunteers, this is actually this is Chris Kaler, the kind of the leader of the program. If you ever go, he's quite the character. He did several costume changes throughout the several days of the build. This was his Superman phase, as it were. I think he'd done Thor earlier that day as well. But he's here doing the final checks on our setup before integrating it with the rest of everything to go into space. So after we put everything together in these cans, we actually brought them over to Wallops Air Force Base to be integrated into our rocket. We were able to watch that, and then they also took us on a guided tour of the building where they manufacture the rocket parts, as well as a building where they build and test high altitude balloons. Bring 8,000-pound satellite grade experiments up to near space, which is really fun to watch.
That picture on the top left is the Christmas tree test. It was the final test before sealing everything up, just making sure that all of the experiments were responding correctly to the signal that would enable them right before launch. Each of those red LEDs is connected to one of the Rock On team's experiments. And we actually got to go out and see the launch in person. It was just so amazing to see. The video doesn't do it justice.
However loud you think it might have been, it was louder. Braving the early morning hours definitely worth it. See, it just rockets off that pad. It disappears. Everybody I show it to is quite surprised at how fast it goes. So to recap, we actually had an official post-flight NASA briefing. Successful launch to 185 kilometers and recovery. The upper stage splashed down in the ocean, was recovered by boat. Everything functioned the way it was supposed to be. I don't think I've ever been more excited to get my hands on spreadsheet data.
And here's the graphs of our data. We went through and looked at the accelerometer, and we could see where the first stage was going, and then it cut out for about 9 seconds before the second stage started going. And you could see that really clearly in the accelerometer data. And then looking at the Geiger counter data, we can see that there's a lot more radiation up in space than on the ground.
Cracking open the data and trying to make sense of it was really rewarding. Asking ourselves why something looked like it did in the data, and then proposing explanations and trying to match it up with the flight schedules was really fun. You could see these vertical lines, for example, when the stages, between stages, and then for the X and Y axis acceleration, you see it's spinning at a certain rate because the sensors were not quite in the center of the plate, and then you could see where they despun the rocket very quickly, and that those side forces negated out. It was really fun experience just looking through that. We learned a lot about physically putting Arduino projects, including soldering and preparing for rocket launches. Another key thing that happened there, and the way it's set up, you find a lot of camaraderie and excitement from fellow students, both from working with and people that you've never met before who are equally as excited about what's going on as you are. Since the event, our super team that sat us at the same table with us here from Delgado Community College in New Orleans, we've been chatting back and forth and sharing pictures and making plans for the future. So it definitely, that's an aspect of this that can't be understated.
It was a great experience, just so fast-paced. In just 10 days, we put everything together and got to see it go into space and get our data back and look at it. It just made me so excited to do a future project. I would love to come back for RockSat, where you design the entire project from the ground up. And we'd like to thank everyone from the Iowa Space Grant Consortium and Des Moines Area Community College who made it possible to go on this trip for this wonderful experience.
Thank you so much.